It's number one, and no coincidence. Hydrogen is the simplest and most abundant atom in the universe. 2 hydrogen atoms and 1 oxygen atom make water, the molecule of life. But this light gas doesn't just hydrate, it's also the fuel of stars. When you look at the sun, you're seeing hydrogen fusing itself to release light and heat. And if that's not enough, it's the clean energy dream of the future. Controlled nuclear fusion, no waste, just power. The most curious thing? It's so light that if you let go, it escapes Earth's atmosphere and is lost in space. An element that isn't content to stay still. It was born in the Big Bang and hasn't stopped making history ever since. Literally, universal history. It's the king of passivity, but that doesn't mean it's boring. Helium is the second lightest element and the second most abundant in the universe, just after hydrogen. It doesn't react with almost anything. It's the hermit of the periodic table. But it has a superpower. It never freezes at atmospheric pressure. If you cool it enough, instead of solidifying, it enters a quantum state called superfluid. It can climb the walls of the container as if it had a will of its own. It's also the gas in floating balloons, responsible for high-pitched voices at parties and the silent coolant in MRI scanner magnets. And you know what else? It's so rare on Earth that every time it's released, it's lost forever, literally, to space. A noble gas with class, with mystery, and that, despite its lightness, carries weight everywhere. Lithium is the lifeblood of your devices. Without this small, silvery metal, your phone would be just a shiny brick. It's element number 3, but number 1 in rechargeable batteries. Lightweight, reactive, efficient. You don't see it, but you're surrounded by it, in electric cars, laptops, and satellites silently orbiting the Earth. But that's not all. Lithium is also used in psychiatric treatments to stabilize mood, a metal that can calm mental storms. How can we not respect it? Extracted mainly from giant salt flats in South America, it has become a key geopolitical resource, like the white oil of the 21st century. A silent, yet essential metal. Technology, healthcare, mobility, all thanks to the third smallest element in the universe, which silently moves the world. Beryllium. A fancy name for a truly hard element. Light as aluminum, yet rigid as steel. It's the secret behind many high-performance technologies. It's used in airplanes, satellites, and even space telescopes like the James Webb, where every milligram counts. It's transparent to X-rays, making it vital for medical and analytical equipment. But beware. Inhaling its particles is toxic, and working with it demands respect. It's the silent guardian in systems that can't fail. Want more? In the stars, beryllium is forged in cosmic explosions that defy human logic. We don't see it shine, but without it, many future structures wouldn't exist. It's an example of how the invisible can sustain the essential, and like the best heroes, it doesn't need the spotlight to be indispensable. Boron, the outsider of the periodic table. It's not a metal, it's not typical, and it doesn't let itself be pigeonholed. But when you understand it, it changes the way you see chemistry. It forms geometric structures that seem designed by futuristic architects. Its compounds are key in resistant glass, detergents, and optical fibers. Did you know that the famous Pyrex glass owes its strength to boron? And it's not just a laboratory wildcard. It has potential in nuclear medicine, semiconductors, and even reactor materials. It's the scientific wildcard. It appears where you least expect it, and always improves whatever it touches. Although rare, boron is like that rare piece that fits into every puzzle. If it were a person, it would be the eccentric genius who appears once a decade and changes everything, without any fuss. With boron, science becomes architecture, and the periodic table, an art gallery. Carbon. The linchpin of life, the fourth most abundant element in the universe, but the most biologically important. It's in your DNA, in your toast, in the air you exhale, but also in diamonds, in graphite, in nanotubes. Versatility. Infinite. Carbon can form more compounds than all the other elements combined. It's nature's Lego. With 4 possible bonds, it adapts, connects, creates chains, networks, rings. Life wouldn't be possible without that flexibility, but it doesn't just live in you. It's also the basis of the hardest and softest materials. It's a conductor, an insulator, a structure, a soul. And in the midst of the climate crisis, carbon is at the center of the debate. CO2, climate change, capture and storage. An element that's not just part of us. It's the mirror of our evolution and of our decisions. And nitrogen is the ninja of the air. Invisible, silent, but absolutely vital. Although it represents 78% of the atmosphere, we breathe it without realizing it. And yet, we don't use it directly. We need bacteria to transform it into forms our cells can assimilate. Without nitrogen, there are no proteins, no DNA, no life. And yet, it is so stable in gas form that only with lightning, microorganisms, or laboratories can it be turned into something useful. It is also a brutal refrigerant. When in liquid form, it can freeze flowers in seconds or preserve biological samples for decades. It is used in the food industry for packaging, in medicine, and even in airbags, an element that makes no noise, but without which nothing would work. It is air without glory, but with a mission. Oxygen, the breath of the world. The name that invokes life, fire, and transformation. You breathe it, you burn it, you combine it. It's the second most abundant element in the atmosphere and the first in your blood. But it can also be lethal, pure, concentrated. It can oxidize metals in seconds or burn furiously. It forms water, it forms oxides, it forms ozone. It's in your brain and your muscles, and without it, the humblest cell shuts down. Fun fact, it was discovered twice by two different scientists almost simultaneously, and although we associate it with life, it's also the agent of aging. Oxygen oxidizes, degrades, consumes. It is both a giver and a destroyer. It is so essential that when it is missing, everything stops. It is the spark behind every electrical impulse in your body. You breathe, you think, you walk, thanks to this colorless and treacherously powerful gas. Fluoride is a little rebel. It's the most electronegative of all. Wherever you put it, it steals electrons with unique ferocity. It's so reactive that it doesn't exist free in nature. It must be released carefully. And what purpose does something so aggressive serve? Well, to protect your teeth. Fluoride in small amounts strengthens tooth enamel. But in large doses, it can corrode whatever it touches. It's also used in Teflon, that non-stick material that coats your pans. Imagine cooking without anything sticking. Thank fluoride. And in medicine, it helps obtain precise images in positron emission tomography, PT scans. An extreme, unpredictable element, and vital in minimal doses. It's the paradox of the periodic table, a potential villain, but an everyday ally. Just treat it with respect, like all truly powerful things. Neon, the nocturnal artist. It has no color, no smell, no taste. But when excited, it shines like an electric god. It's one of the noble gases, completely inert, and doesn't mix with anything, except with voltage. In the 1920s, it filled cities with bright signs and impossible colors. Although in reality, pure neon only glows orange-red. The other colors come from other gases, but no one took away its credit. It became synonymous with modernity, with signs, with the city that never sleeps. It's also used in lasers, voltage indicators, and even cryogenic refrigeration. It doesn't react, but it does create visual history. It doesn't bond with anyone, but it leaves its mark wherever it goes. Neon is more than a gas. It's a symbol of the modern age, silent but impossible to ignore. Sodium, the metal that burns in water. But it's not just an explosive reaction, it's the foundation of how you function. Without sodium, your body doesn't transmit impulses, your muscles don't respond, your mind doesn't ignite. Every heartbeat, every thought, depends on that charged ion coursing through your neurons. And although we find it in table salt, pure sodium is a rebel. Soft, shiny, and so reactive that it needs to be sealed in oil. It was isolated by Humphrey Davy in 1807, and since then we've used it in everything. Street lighting, glass, the chemical industry. It's energy compressed into metal. It's a symbol of life and risk. Sodium is in the sea, in our blood, in history, and although we underestimate it, without it, the body shuts down. It's not a mineral, it's a biological spark. So the next time you think of salt, remember that every grain contains the possibility of igniting the most complex machine in the universe, you. Magnesium, It doesn't shine, it dazzles. When you light it, it explodes in pure white, like a mini star. But this light metal isn't just fireworks. It's the mineral of the nervous system, of muscles, of balance. It's in your bones, your brain, and every cell that wants to function without collapsing. Magnesium aids more than 300 biochemical reactions. Without it, you literally shut down. Joseph Black discovered it in the 18th century, but it was Sir Humphrey Davy who isolated it. Today it's found in antidepressants, supplements, airplane metal bands, and even rescue flares. It's the silent metal that keeps the machinery running. And although it's not worshipped, without it, there would be no cellular dance, no muscle recovery, no mental clarity. Its balance in the form of an atom, magnesium doesn't scream at you, but it's there, sustaining everything. Invisible and essential, like all real force. Light as a feather, strong as a shield. Aluminum is the metal that transformed the modern world without you even realizing it. It doesn't rust like iron. It's as heavy as steel, and it's everywhere. Airplanes, cans, smartphones, windows, cables. The curious thing is that it's one of the most abundant elements in the Earth's crust, but it's never found pure in nature. Only in the 19th century, with electrolysis, did we manage to isolate it. Before, it was more expensive than gold. Today, its lightness and ability to form alloys make it essential. But it's also in your body. In tiny traces, we ingest it constantly. And although it's useful, too much can be neurotoxic. Aluminum is a paradox. Invisible, everyday, indispensable. A silent giant of the modern age. The next time you open a can, touch your phone, or look at an airplane wing, remember that you're touching the metal that democratized engineering. Light, shiny, versatile. That's aluminum. You don't see it, but without it, you wouldn't read this. Silicon is the heart of the digital revolution. The second most abundant element on Earth. It's found in sand, glass, and chips. It's a metalloid, and that makes it special. It can conduct electricity, but with control. That almost gave the world transistors, and with them, computers. Every click, every message, every search has a silicon atom behind it. But it doesn't end there. It's also in your body. It regulates tissues, strengthens bones, and participates in cellular processes. Technology adores it, biology needs it. From a mountain to a microchip, silicon unites the mineral with the human. It has something magical about it. It turns sand into thought. It's discrete, but without it, there would be no screens, no networks, no AI. Silicon doesn't shine, but it connects. It unites worlds. It is the atomic symbol of the present, and in every bit it travels, it carries with it a spark of the future. Silicon, the bridge between the inert and the intelligent. Phosphorus, the light bearer. Literally, its name means the one who carries light. It was discovered in 1669 in a macabre way, by heating urine. Today you find it in your bones, your DNA, your brain. Without phosphorus, there is no cellular energy. There is no movement, there is no life. There are several forms: white phosphorus, lethal and brilliant, red, more stable, and black, mysterious. It is used in fertilizers, detergents, and weapons. Its dual face reflects that of human beings, creation and destruction. You carry it inside, but it can kill you. It illuminates, but it also burns. It is in every cell like ATP, the energy molecule. Phosphorus is invisible fire, an active presence. Without it, everything that moves stops. Everything that grows dies. It is the internal lightning of your body, the one you don't see, but it ignites your life every second. Sulfur, the element of alchemists. Bright yellow, smelling like rotten eggs, but essential. You find it in volcanoes, in proteins, in your hair. It's one of the pillars of life. It participates in enzymes, in vitamins, in the body's defenses. Its symbolism has been dense. Hell smelled of sulfur. But without sulfur, life as we know it would not exist. On Earth and in the body, it is transformation. It burns blue, purifies metals, forms bridges in the proteins that sustain you. We use it in fertilizers, tires, medicines. It is strong, yet ductile. Ancient, yet modern. In the body, it stabilizes. In symbolism, it shakes. Sulfur is the witness that life is built with the dark, with the strange, with that which doesn't smell good, but also with that which resists. It is an elemental paradox, vital ugliness, invisible function, volcanic power. Chlorine, a dense, pale green gas with an ambiguous history. In World War I, it was a chemical weapon. Today, it purifies your water and cleans your swimming pools. It's responsible for killing bacteria, but it can also damage human cells. Ambivalent, necessary, dangerous. In the human body, it exists in the form of chloride, a vital ion for maintaining fluid balance and nerve transmission. On the periodic table, it's a halogen, and like all halogens, it's highly reactive. Chlorine doesn't go unnoticed. It oxidizes, changes, transforms. In chemistry, it represents synthesis and rupture. In society, it represents purification and control. Common salt contains it, but its pure essence is hostile. It's a symbol of civilization. Where there is chlorine, there is cleanliness. But it's also a reminder that all power must have limits. In excess, it destroys. In precise doses, it saves. Argon, the noble gas that doesn't react with anything, silent, colorless, invisible. But it's there. It's the third most abundant gas in the atmosphere. It doesn't make any noise, but it protects. It's used in lamps, in welding, in environments where chemistry shouldn't be spoiled. In the periodic table, it's a noble gas, and it honors it. It doesn't mix, it doesn't oxidize, it doesn't interfere. In Greek, its name means inactive. But its inactivity is its virtue. In a world that demands action, argon teaches us to be unpolluted, to protect without intervening. In the symbol, it's the silent guardian. In real life, it's a protective gas. You don't see it, you don't smell it, but it's present in every step of science that needs an invisible shield. Potassium. Sodium's brother, but more explosive. Its symbol is K from the Latin kalium. It's a soft metal that explodes upon contact with water, but inside you it doesn't destroy. It balances. It regulates your pulse, your muscle contractions, your electrical impulses. Without potassium, your heart won't beat rhythmically. It's one of the body's great electrolytes. It's found in bananas, spinach, and potatoes. On the periodic table, it's a fierce alkaline. But in your body, it's bioelectrical peace. Potassium represents the right tension. Without it, collapse. With it, rhythm. It's a symbol of the vitality that cannot be seen, of that which explodes if isolated, but gives life if integrated. It's the element that shines without you noticing. But if it's missing, everything goes out. Calcium. The architect of your bones, your teeth, the structure that supports you. But it's not just a mineral, it's a signal, a messenger, energy in solid form. More than 99% of the body's calcium is found in the bones. The remainder regulates contractions, coagulation, and cellular communication. It's necessary from birth to death. We find it in dairy products, vegetables, and nuts. A deficiency weakens, an excess calcifies. In chemistry, it's an alkaline earth metal. It reacts with water, shines in fire, and is a component of marble, plaster, and cement. In symbols, it represents solidity, but also biological flexibility. Calcium builds you, repairs you, and sustains you. It is the physical basis of movement and the background silence of your cellular energy. Everything you can imagine, nature has already created, said Albert Einstein. Scandium doesn't appear in everyday life, but it's present in engineering dreams. This light and strong metal was discovered in 1879 and is one of the rarest elements on Earth. However, its lightness and strength make it a technological gem. It is used to strengthen aluminum alloys in aircraft, high-performance bicycles, and sports equipment where every gram counts. On the periodic table, it is the first of the transition elements, discrete but essential. Its rarity and efficiency make it expensive, but irreplaceable in contexts where precision matters. One of its greatest enemies is oblivion. Because it is not well known, many underestimate its impact. But without scandium, lightweight progress would be heavier. It is a symbol of what works silently, small details that support large structures, a reminder that scarcity can be decisive. The art of war is to subdue the enemy without fighting, said Sun Tzu. Titanium doesn't need to fight, it simply endures. It is the metal that defies corrosion, heat, and time. Light as aluminum but as strong as steel, titanium is found in airplanes, prosthetics, submarines, luxury watches, and rockets. It is a symbol of resilience and technological elegance. Its name comes from the Greek Titans, and it lives up to them. It is tenacious, powerful, and withstands extreme conditions without losing its shape. It is found in the sand, in the human body, and in the stars. One of its enemies is its difficulty in processing. Extracting and molding it is complex and expensive, but the result is worth every effort. Titanium does not rust, does not bend, does not surrender. In a world that is breaking apart, titanium remains. It represents the ideal of the serene warrior, strong, noble, resilient. It is the choice of those who build to last, and it reminds us that true strength is silent. Vanadium is balance in metallic form. Its name comes from Vanadis, the Scandinavian goddess of beauty, but its true value is functional. Discovered in the 19th century, it transforms steel with just 0.15%, making it harder, more flexible, and more resilient. It's found in bridges, motors, surgical tools, and structures that must withstand breaking. It's also key in flow batteries for future energy storage. In pure form, it's unstable, but when integrated into alloys, it provides power without being noticeable. On the periodic table, it's a transition metal, discreet and effective. Vanadium represents improvement without arrogance, silent strength. It reinforces without dominating. It is a symbol of adaptation, stability, and precision. A metal that doesn't shine, but sustains. Beauty is a promise of happiness, said Stendhal. Chromium transforms matter into shine. It's found in cars, faucets, appliances, everything that reflects luxury and style. But it's not just about looks. Its coating protects, prevents rust, and extends lifespan. In alloys like stainless steel, it's key to durability. It also acts on the human body, regulating blood sugar in very small doses. Chromium has two sides, one useful and protective, the other toxic and dangerous. Its trivalent form nourishes, the hexavalent poisons. Misused, it pollutes. Used well, it preserves. Chromium is duality, light and shadow, beauty and risk. It teaches us that brilliance can save or destroy. It all depends on how it's used. Order is the pleasure of reason, but disorder is the delight of the imagination, said Paul Claudel. Manganese doesn't shine or sparkle, but its presence orders worlds. It is an essential metal in the manufacture of steel. Without it, iron becomes brittle. Manganese gives hardness, toughness, and resistance to wear. It is found in railroad tracks, in heavy tools, and in structures that must last. In the human body, albeit in small quantities, it participates in bone formation, metabolism, and antioxidants. It is vital, though little seen. Its greatest enemy is ignorance. Many don't know that without manganese, steel would be brittle, cellular life less efficient. In the periodic table, it is a transition metal with multiple oxidation states, which makes it versatile and somewhat unpredictable. It is the wild card of industrial chemistry. It represents the strength of silent support, of reinforcement that doesn't boast. Manganese is just that, a stabilizer that holds up without being seen, a hero from the depths of the system. Iron, the core of our planet and also of our blood. Without it, there is no civilization nor oxygen in our cells. From ancient swords to modern skyscrapers, iron is history and structure. It rusts easily, but it also transforms into steel, bridges, and trains. In the human body, it carries life through hemoglobin. A lack of it generates fatigue, an excess, damage. It is a symbol of strength, but also of fragility if allowed to corrode. Iron represents the will to endure, the backbone of what remains. Cobalt, deep blue like the ink of dreams. Its name comes from the German word kobold, meaning goblin, because it deceived miners with its appearance. But cobalt is real and essential, vital in rechargeable batteries, turbines, and pigments that last for centuries. In the human body, a tiny amount helps create vitamin B12. In technology, it sustains the energy of the future, dual and complex. In medicine, it emits radiation to save lives. In mining, it can destroy environments and communities. Cobalt is dangerous beauty, concentrated power, the blue that drives and demands responsibility. Nickel, the metal that doesn't rust in the face of adversity. It shines like silver, but is as resilient as steel. It's found in coins, surgical instruments, batteries, and armor. It's key in alloys that withstand heat, pressure, and time. On Earth, we even find it in meteorites, a space traveler, a witness to our origins. Its name comes from a mining demon, Old Nick, because it looked like silver but wasn't. Today, nickel supports structures, transmits electricity, and enables new forms of energy. It is a symbol of rugged adaptability, of resilience without boasting. Copper, the red metal that connects us. Since ancient times, it was one of the first to be worked by humans. Today, it is the soul of cables, the nervous system of our cities. It conducts electricity, heat, and also history. In the human body, it participates in the formation of red blood cells and collagen. Its warm color recalls blood, earth, and fire. It is soft, but essential. Without copper, there is no connection, no communication, no flowing energy. It is at the foundation of technology, though never at its center. Copper is electrical humility. Zinc, the discreet guardian of your immune system. It doesn't shine like gold or conduct like copper, but without it, the body loses balance. It's vital for healing, growth, and defense. In industry, it protects steel from corrosion, the invisible coating that prevents wear. Its name sounds brief, but its impact is profound. In alloys, in creams, in cells, zinc is where it's needed without demanding attention. It represents functionality over the spectacular, a silent protector, the shield that can't be seen, but is always there. Gallium, the metal that melts in your hand, surprising, malleable, almost magical. Its melting point is just above body temperature, making it a symbol of subtle transformation. It was discovered in 1875 and predicted by Mendeleev before its discovery. It's used in semiconductors, LEDs, and solar panels. Technology with a liquid soul. Gallium doesn't exist free in nature, but appears in minerals as a hidden secret. It represents that which flows without evaporating, that which adapts without losing its shape. It's a metaphor for liquid intelligence. Germanium, brilliant like a diamond, but conductive like silicon. This metalloid was key to the electronics revolution of the 20th century. It's found in fiber optics, infrared sensors, and solar panels. Its rarity makes it valuable, its purity indispensable. It appears grey, but in function it is technological gold. It was discovered in 1886 and, like gallium, also predicted by Mendeleev. Germanium is the logical mind of silicon with a structural elegance all its own. It is a symbol of the invisible precision that connects the modern world. Arsenic, the most famous poison and also an essential element. Its duality is disturbing. It can kill in minimal doses or cure in specific contexts. It has been used as a weapon, as a medicine, and as a pigment. Emerald green in art and in poisoning. On the periodic table, it's a metalloid that defies categories. It's found in pesticides, alloys, even cancer therapies. Arsenic represents the edge between the useful and the lethal. It's a warning that unethical knowledge can be toxic. Selenium. Its name comes from Selene, the Greek goddess of the moon. It shines invisibly, essential for health, key in technology. In the human body, it acts as an antioxidant, defending cells from damage. In industry, it's used in photocells, glass, and photocopiers. It has semiconductor properties that make it useful in converting light into energy. Its presence is subtle but powerful. In excess, it's toxic. In the right amount, it's vital. Selenium represents lunar balance, serene brilliance, silent defense. Bromine. Its name means stench in Greek, and it's the only non-metallic element that's liquid at room temperature, along with mercury. Reddish, toxic, and volatile. It's used in flame retardants, pharmaceuticals, and photography. Its odor is pungent, its action potent, its reactive, unstable, and disturbing. It represents the uncontrollable nature of chemistry, that which cannot be ignored. In nature, it appears dissolved in sea salts and springs. Bromine is a warning, a power that demands respect. It doesn't seek attention, but commands it. Krypton. Its name evokes mystery. It means hidden in Greek. It is a colorless, odorless, noble gas that rarely interacts with other elements. It is found in small quantities in the atmosphere, but its presence has been key in high-precision lamps, photographic flashes, and plasma technologies. In science fiction, it gave its name to Superman's home planet. But in reality, Krypton represents the reserved, the quietly powerful. Its light is cold, its energy discreet but firm. Krypton is presence without prominence, energy without noise. Rubidium. The rebel of the alkali metals. So reactive that it burns on contact with air, so soft that it cuts with a knife. It was discovered thanks to its characteristic color in the spectrum, a deep red that gives it its name. Rubidium is not found free in nature, but is abundant in minerals. It is used in atomic clocks, space research, and the manufacture of special glass. It is a young, restless, impatient metal. It represents what explodes if not contained, pure energy waiting to be channeled, a warning that even soft things can burn. Strontium, the red color of fireworks, the bright pulse in the night. This alkaline earth metal has unexpected uses, from pyrotechnic art to medical studies on bones. In its pure state, it is soft and silvery, but reacts quickly with water and oxygen. It is found in minerals and also in the oceans. Its radioactive form can be dangerous, but its stable form is safe and useful. Strontium is spectacle, but also medicine. It represents the spark that illuminates the hidden, the fire that does not burn, but transforms. Yttrium. A transition metal that doesn't attract much attention, but underpins advanced technologies. It's found in LED displays, superconductors, and heat-resistant ceramics. It's essential for making stronger, more stable, and more durable materials. Its name comes from Ytterby, a Swedish village where several rare elements were discovered. Yttrium isn't visible in your everyday life, but it's in almost everything you use. It represents the hidden foundation of innovation, the foundation that doesn't seek credit, but without which nothing works. Zirconium. Brilliant, durable, and versatile, often confused with diamond due to its crystalline form, zircons, its true power lies in nuclear reactors, medical implants, and aerospace alloys. It doesn't corrode, rust, or yield to the passage of time. It was discovered in the 18th century, but remains a metal of the future. Zirconium is beautiful and useful, stable and sophisticated. It is a symbol of silent permanence, of technical beauty. The shield that is not noticed, but without which there would be no protection. In niobium. The metal that strengthens without boasting. It's added to steel to make it stronger, lighter, and more durable. We find it in bridges, oil pipelines, turbines, and particle accelerators. It's stable, ductile, and rare. Its name comes from Greek mythology, Niobe, daughter of Tantalus, a symbol of silent resistance. Niobium doesn't seek the limelight, but without it, many infrastructures would collapse. It represents the improvement that isn't boasted, the strength hidden within the structure. Molybdenum. Gray, dense, essential, withstands extreme temperatures without deforming. It's used in special steels, engines, and nuclear reactors. Its name means lead in Greek, but its function is unique. In small quantities, it changes everything. It's also vital to life, enzymatic, discrete, profound. It represents industrial resilience, the detail that makes the difference. Molybdenum is the guardian of heat, the shield that doesn't melt. Technetium. The first element created by humans before being found in nature. Artificial, radioactive, rare. It's used in nuclear medicine to trace organs and diagnose diseases. Its history is modern, its usefulness vital. Technetium represents the science that creates what didn't exist before, the exploration of the invisible. It's not stable, but it is precise. A symbol of knowledge that doesn't wait for nature, the invention that saves. Ruthenium. A rare, greyish, durable metal. It belongs to the platinum group but has its own unique signature. It's used in electrical contacts, sensors, and alloys that must last. In small doses, it improves materials and extends their useful life. Ruthenium is the technical ally of perfect detail. Its name honors Russia, but its reach is global. It represents microscopic precision, solidity without bulk, minimum with maximum impact. Rhodium. One of the most expensive metals in the world, silvery, shiny, and unalterable. It's used in car catalytic converters, jewelry, and electronic components. It resists corrosion like few others. It's a symbol of functional luxury, of rarity with purpose. Its scarcity makes it valuable, its efficiency indispensable. Rhodium represents the elegance of extreme utility, something precious that also serves a purpose. Beauty that doesn't tarnish. Palladium. Flexible, rare, powerful. It absorbs hydrogen like a sponge and catalyzes essential reactions in industry. It's found in catalytic converters, watches, and mobile phones. Its discovery came after platinum, but its impact is equal to its own. It's light yet strong, expensive yet necessary. Palladium represents the balance between nobility and functionality, between the discreet and the decisive. The metal that makes transformation possible. Silver. The metal of the moon, medicine, and commerce. It shines like no other, conducts electricity better than all. Since ancient times, it has been a symbol of value, purity, and transaction. It is found in coins, circuits, jewelry, and antibiotics. It is noble, but also practical. Silver is beauty that heals, the ancient that remains relevant. It represents the link between tradition and technology. A mirror that reflects both the past and the future. Cadmium. Soft, ductile, dangerous. It's a silvery metal that has been used in batteries, pigments, and anti-corrosion coatings, but its reputation is tarnished. It's toxic, cumulative, and silent. It enters the body and doesn't leave. It lurks in industrial waste and tobacco smoke. Despite its usefulness, its shadow is long. Cadmium is a pure warning. What seems harmless can be lethal. A reflection of the chemical age that shines and pollutes at the same time. Indium. The metal that screams when bent. Literally, when bent, it emits a high-pitched, unique squeal. It's rare, soft, and silvery. It's found in touchscreens, solar panels, and semiconductors. In the modern world, indium is invisible but essential. You don't see it, but it connects you. Its scarcity makes it valuable, its ductility functional. Indium represents the subtlety that sustains the everyday. A metal of the present that came from the rare. Tin, the humble protector. Since ancient times, it has been used to coat other metals and prevent corrosion. It forms part of bronze, along with copper. Without tin, there is no Bronze Age. Flexible, durable, and easy to mold. It's found in tins, circuits, and solders. It doesn't shine like gold, but it preserves everything. Tin is the humble thing that holds the world together. An element of nurturing bonding and permanence. Antimony, fragile luster, dense history. From ancient Egypt to medieval alchemy, antimony has been a mystery, a medicine, a makeup, and a metallurgy. In small doses, it was a remedy. In excess, a poison. It's used in flame retardants, batteries, and specialty glass. Its pure form is brittle, but in alloys, it gains strength. Antimony symbolizes the paradox. The toxic protects, the weak reinforces. An alchemist trapped in the periodic table. Tellurium, rare, lustrous, with a garlicky aroma. It's used in solar panels, semiconductors, and specialty alloys. Although metallic, it behaves like a non-metal. In large quantities, it can cause toxicity in humans, leaving an unforgettable breath odor. Its name comes from the word Earth, but its use is cosmic in technologies aimed at space. Tellurium represents the exotic, which doesn't fit easily, but is key. The rare metal that finds its place in the future. Iodine. The dark side of medicine and memory. Essential for the thyroid, vital for the mind. Its lack causes retardation. Its presence activates intelligence. Once used to disinfect wounds, today it's part of the salt we eat every day. Dark, shiny, almost violet. It appears like mist when in contact with the air. Iodine is the element that doesn't shout, but regulates metabolism. A subtle side that brings clarity to everything it touches. Xenon, the noble gas that shines in silence. Colorless, odorless, and reactionless until it's ignited. It's used in intense lights, in general anesthesia, and in ion engines that travel through space. It's rare, expensive, but decisive. Xenon represents the mystery awaiting the spark, the inert that, under the right conditions, dazzles. It's the reminder that even the quietest things can illuminate the universe. Cesium, the golden metal that explodes in water, extremely reactive, extremely precise. It's used in atomic clocks, where it measures time with an accuracy that defines the second. It's soft, shiny, dangerous. Its name comes from the sky blue, from the lines it emits. Cesium is a paradox, chemical violence and chronological perfection, time made into a contained explosion. Barium, the contrast that reveals the hidden. In medicine, it allows us to see inside the body. In industry, it stabilizes glass, ceramics, and paints. Pure, it is reactive and toxic. Combined, it is a precision tool. Its name means heavy, and it is in function and form. Barium represents what makes the invisible visible, the intermediary between shadow and form. Lanthanum, the gatekeeper of rare elements, soft, malleable, lustrous, used in camera lenses, hybrid batteries, and specialty steels. It marks the beginning of the rare earths, that group of metals that sustain the modern world without anyone noticing. Lanthanum is openness, beginning, foundation, a transition metal in the deepest sense, between the commonplace and the astonishing. Cerium, the silent fire. This rare metal is used in lighter flints, tiny sparks that ignite bonfires. It's also used in specialty glass, catalysts, and precision polishing. It's soft, oxidizable, seemingly common, yet essential. Cerium is the hidden spark, the one that doesn't shine alone, but initiates the glow. A lighter of change. Praseodymium, green, rare, and powerful. Its name means green twin due to its resemblance to neodymium. It's used in welding glasses, high-performance magnets, and electric motors. It's part of the technical soul of today. Praseodymium is like a green thread that unites rarity with utility, industrial brilliance, discreet heart. Neodymium, the most powerful magnet on the planet. Tiny pieces of neodymium hold headphones, hard drives, and wind turbines together. Without it, the modern world loses its power. Although it's a grey metal, its impact is vibrant. Neodymium represents the invisible that attracts, the small that moves the large, hidden strength, absolute precision. Promethium, the only rare earth element that is completely radioactive. It does not exist in a stable form. It was discovered in the remains of nuclear fission. Its name honors the Titan who stole fire from the gods. It is used in satellites, space batteries, and research. Promethium is myth-made atom, a stolen fire, unstable, brilliant, and dangerous. Samarium, the balance between strength and control. It's used in magnets, nuclear reactors, and special glass. It helps filter radiation, contain heat, and strengthen materials. Its name comes from a mineral, and its function comes from necessity. Samarium is discreet, but key. It supports without weighing, stabilizes without imposing. The art of intelligent reinforcement. Europium, the one that makes screens shine. Without this rare metal, the vivid colors of televisions and fluorescent lamps would lose their soul. It's used in security, technology, and nuclear tracers. Its light is reddish, deep, and precise. Europium is like the final accent in a well-done project, subtle but essential. It gives tone to the digital world. Gadolinium, the guardian of magnetism. It has a unique affinity for magnetic fields and is used in MRIs, nuclear reactors, and advanced materials. It is dense, strong, yet flexible at the atomic level. Gadolinium represents the force that guides without pushing, the balance between control and sensitivity. Science applied to detail. Terbium, green in name, technical in spirit. It's used in LCD screens, sensors, and vibration-absorbing alloys. It's a ductile metal that rarely acts alone, but enhances everything it touches. Terbium is the subtle reinforcement, the precise tone, the restrained vibration. A hidden engineer within matter. Dysprosium, the one that resists heat and chaos. This metal doesn't just withstand extreme temperatures, it embraces them. It's found at the heart of magnets that must maintain their strength even inside electric motors, wind turbines, and nuclear reactors. Where common metal gives way, dysprosium resists. Its name, which means hard to obtain, reflects both its rarity and its stubborn nature. It's not a metal for display cases. It's for supporting critical structures when everything is burning, when everything is vibrating. Dysprosium doesn't seek the limelight, but it is the backbone of the technologies that move the world. The metal of tenacity, the one that doesn't deform under pressure, the one that remains intact at the very heart of movement. Holmium is the silent guardian of magnetism. It possesses the most powerful magnetic field of all the elements, yet its name is rarely spoken outside of technical circles. It comes from Holmia, the Latin name for Stockholm, and like that city, it is discreet, elegant, and powerful. It is found in high-precision medical lasers, nuclear shielding, and alloys designed to withstand extreme conditions. Holmium is contained power, not the one that shouts, but the one that sustains. Its magnetism attracts not through spectacle, but through conviction. It represents those who influence without needing to dominate. An invisible compass in technological chaos, the center of gravity of the subtle. Erbium is the color that cannot be seen, but that changes everything. It tints the optical fibers that carry data across the planet pink. Its hue is not a whim. It is functional, fine-tuned to the precision of modern telecommunications. It is also involved in laser medical treatments and in special glass that filters and shapes light. Erbium doesn't need to shine because it already transmits. It is technical elegance, a soft yet essential presence. A metal that embodies the beauty of what it allows without imposing. It sustains global communications with the grace of one who is barely noticeable, yet sustains everything. A silent messenger of light, an artist of the invisible. Thulium is the best-kept secret among rare metals. So scarce it seems a whisper on the periodic table, yet so precise that its value is measured not in grams, but in impact. It is found in portable X-rays, in surgical lasers, in ceramics that must withstand extreme temperatures and stresses. Thulium is the luxury of necessity, a metal that is scarce but irreplaceable. Its energy is surgical, its utility millimetric. It represents that which, although small, changes everything when it is in its place. The jewel of precision. The symbol that what is rare is not strange, but essential at the right moment. Erbium is the tuner of the modern world. Soft, metallic, almost anonymous, but with unique properties when subjected to pressure. It is used in seismic sensors capable of detecting earthquakes, in high-stability lasers, and in atomic clocks that keep time with almost absolute precision. Ytterbium doesn't shine to dazzle, it calibrates. It doesn't dominate, it detects. Its mission is not to stand out, but to balance. It represents those who adjust frequency, those who give tone and scale without the need for noise. Ytterbium is the tuner, the regulator, the maintainer of order amidst movement, the metal that translates vibrations into precision. An invisible conductor, but indispensable. Lutetium, the last of the lanthanides, but certainly not the least. It's used in PET scanners, catalysts, and geological studies. It's one of the densest and most expensive elements. Its name honors Paris, Lutetia. Lutetium represents the ultimate that sustains, the crowning glory of the rare earth, the discrete weight of precision. Hafnium, the core stabilizer, used in nuclear reactors, electronic chips, and high-temperature alloys. It absorbs neutrons like few others, and resists heat like even fewer. Discovered in Copenhagen, it bears the city's Latin name. Hafnium is the guardian of extreme energy, solid, invisible, crucial, the technical shield of fission. Tantalum, the metal that resists everything except myth. Its name comes from Tantalus, condemned to eternal thirst. Curiously, tantalum doesn't dissolve in acids, not even in aqua regia. It's used in medical implants, electronic capacitors, and reactor alloys. It's biocompatible, durable, and rare. Tantalum is resistance incarnate. What doesn't corrode, what endures where others decompose. Tungsten. Dense, dark, indomitable. Also known as tungsten, it has the highest melting point of all metals. It's used in filaments, cutting tools, projectiles, and military electronics. Its name comes from German and means wolf's foam, due to its aggressive processing. Tungsten is the silent warrior. It withstands heat and doesn't break. The steel of extremes. Rhenium. One of the rarest and heaviest metals on the planet. It withstands extreme temperatures and is used in jet engines, electrical contacts, and thermocouples. Its discovery came late, but its impact was profound. Rhenium is the patience of the periodic table. The last thing to arrive, but just in time, the one that completes the impossible. Rarity with a purpose. Osmium, the densest of all the elements. Metallic blue, toxic in volatile form, but stable and valuable in solid form. It's used in pen tips, electrical contacts, and catalysts. A pinch is enough to make a difference. Osmium is pure weight, density that speaks. Small things with their own gravity, total presence in a tiny fragment. Iridium. The ultimate toughness. It shines like platinum, but is harder, rarer, and more tenacious. It's found in meteorite debris and in the geological layers left behind by the impact that wiped out the dinosaurs. It's used in surgical instruments, candles, and high-end watches. Iridium is what survives fire and time, the atomic witness to catastrophes and detail. Platinum is the elegance that endures. Rarer than gold, more resistant to corrosion, and more versatile in its uses. It's found in jewelry, yes, but also in catalysts that clean toxic gases, in medical equipment, in electronic applications, and even in cancer treatments. Its rarity makes it a status symbol, but its chemical stability makes it vital in industrial processes. Platinum isn't just beauty, it's functionality elevated to luxury. It represents the nobility that doesn't rust, the presence that doesn't need to shout to make a difference. It is the metal of lasting alliances inside and outside the body. Platinum is a balance between power and discretion, a reflection of what remains when everything changes. Gold. From ancient civilizations to modern financial markets, its brilliance has been a symbol of value, power, and eternity. But beyond the myth, gold is chemically extraordinary. It doesn't rust, it doesn't change, it can be molded to the millimeter, and it conducts electricity with precision. That's why it's found in chips, satellites, and medical prostheses, as well as in rings and ingots. Gold is malleable yet immutable, ductile yet eternal. It doesn't just represent wealth, it's a material that resists time, that crosses eras and civilizations. Gold is the memory of the world, cast in metal. It is both symbol and substance, and it reminds us that what is truly valuable doesn't always change. Sometimes it simply shines. Mercury is the liquid metal. Unique in its state at room temperature, it flows like water, but weighs like lead. It was used for centuries in thermometers, barometers, and industrial processes, although today it is handled with caution due to its toxicity. Its name comes from the Roman god of movement and messages, and honors its restless behavior. It is brilliant, changeable, dangerous, and fascinating. It represents the unstable that reveals truths. Temperature, pressure, the limit. In alchemy, it was the bridge between the physical and the spiritual. In science, it is a shining warning. Not everything that dazzles is safe. Mercury is a moving mirror of ambiguity, a reminder that fluidity can also be heavy. Thallium. The poisoned metal that shines in the occult. Discovered for its green spectral signature, its toxicity made it famous in crimes and poisonings, but its use goes beyond mystery. In small quantities, it is used in radiation detectors, optical crystals, and specialized electronic equipment. Its name comes from the Greek word green sprout, for the glow it emits. Thallium is the embodiment of contrast. Between the lethal and the useful, the invisible and the revealing. It is a symbol of elements that are not meant to coexist, but whose existence reveals dark areas of the physical world. Thallium is a fine line between science and warning. It is a shining echo of what should not be underestimated. Lead, the weight of the past. Used for millennia in pipes, pigments, and utensils, it eventually revealed its toxicity over time. But it didn't disappear. Lead remains useful in batteries, radiation shielding, and high-density materials. It's soft, yet dense. Easy to shape, yet difficult to ignore. Its symbol, PB, comes from the Latin plumbum and still gives its name to the plumber's trade. Lead represents what sustained ancient civilizations, and also what sickened many. It is a warning and a tool, a legacy and a burden. A reminder that technical progress without conscience can weigh heavily. Lead is solid history, and also the cost of learning. Bismuth is the metal with the soul of paradox. Although it is one of the heaviest elements, it is also considered one of the most stable among radioactive elements. It oxidizes, forming iridescent crystals that seem to emerge from a fractal dimension, as if matter were playing with art. It was once used in cosmetics and medicines. Today it is found in gastrointestinal treatments and low-melt alloys. Its toxicity is minimal, especially compared to its neighbor, lead, which it often replaces. Bismuth is a symbol of eccentric beauty and quiet utility. It is a reminder that rarity is not a defect, but a singularity that sustains discrete worlds. Polonium is the most elegant poison in the periodic table. Discovered by Marie Curie and named after her homeland, Poland, this element is extremely radioactive and volatile. A small amount is enough to unleash lethal power. It is used in heat sources for space probes and anti-electrostatic devices. Its existence challenges the tranquility of the table. The fragile becomes potent, the invisible, lethal. Polonium represents the hidden power that needs no volume, only intensity. It is a warning wrapped in science. The radioactive whisper of a world that does not forgive carelessness. An atomic jewel with a sharp edge. Astatine is the shadow at the edge of the periodic table, the rarest naturally occurring element on Earth. Its name comes from the Greek word for unstable, and its life is short. Its isotopes have half-lives of only a few hours. There isn't enough astatine on the entire planet to be observed with the naked eye. But laboratories are studying its potential in nuclear medicine and as a possible treatment for cancer. Astatine represents science at the limits, what cannot be seen, but is intuited. What does not last, but can change destinies. It is a symbol of the fleeting with purpose, the spectrum of the atom that still has something to say. Radon is the noble gas with a dark side, colorless, odorless, tasteless, but potentially lethal. It arises from the decay of uranium in the soil and can accumulate in enclosed spaces, increasing the risk of lung cancer. Despite its toxicity, radon has also been used therapeutically in radiation baths under strict conditions. Its dual nature makes it a haunting presence, invisible yet active. Radon represents formless danger, the threat that breathes within you. But it also symbolizes the use of risk as a controlled tool. It is a reminder that even the air can hold dense secrets. Francium is the lightning bolt in the corner of the periodic table. The heaviest, most unstable, and most ephemeral alkali metal. It exists only in traces, and its lifespan is seconds before disintegrating into other elements. It was discovered in 1939 in France, hence its name, and since then has been more an object of fascination than practical application. Francium represents that which is destined to disappear before leaving a visible trace. It is the beauty of that which cannot be sustained, but which, by existing, completes the map. It symbolizes the unrepeatable, that which need not last to be real. Francium is fleeting atomic fire, a sigh of pure existence. Radium is the radiance that illuminated an era. Discovered by Marie and Pierre Curie, its radioactivity was first a medical miracle, then an invisible curse. It was used in cancer treatments and, sadly, in glow-in-the-dark paints, poisoning those who applied them. Radium emits energy like a miniature star. In medicine, it helped understand and treat tumors. In history, it left an indelible mark on the limits of scientific enthusiasm. It represents the boundary between progress and danger, between cure and condemnation. It is a symbol of that which shines with a double edge, a light that can heal or burn. Radium taught us that science, without respect, can also hurt. Actinium is the original spark of the actinide group, the first in a family of heavy and highly radioactive elements. It glows in the dark with a blue radiance, as if carrying a silent nuclear fire. It is used in thermoelectric generators and nuclear research due to its intense radioactivity. Although rare and difficult to handle, its energy is potent. Actinium represents the beginning of a powerful chain, the gateway to a region of the periodic table where time and matter decompose and transform. It is a symbol of raw potential, of primal energy, an atomic beacon heralding the arrival of the uncontrollable. Thorium is the sleeping titan of nuclear energy. Abundant in the Earth's crust, less dangerous than uranium, and capable of generating clean energy in experimental reactors. It has been called the future of fission, but it has yet to take hold. In ancient lamps, it gave incandescent light. In modern technology, it promises a safer energy renaissance. Its name honors Thor, the Norse god of thunder, and like him, it contains pent-up power, waiting to be awakened. Thorium is potential without release, strength without chaos. It represents what could change the world if shaped. The atomic dream of a wiser energy. Protactinium is the shadow between giants, a transitional element between thorium and uranium, rare, radioactive, and complex to extract. Its history is brief but dense. It was used to understand the behavior of the nucleus and the chains of atomic decay. It doesn't have widespread applications, but without it, our understanding of the uranium cycle would be incomplete. Protactinium represents the intermediate, that which connects what was with what will be. It is a chemical bridge, a technical link, an element that, although brief in usefulness, is key in meaning, the transient that sustains larger structures, the importance of the previous step. Uranium is the nucleus of the 20th century, fuel for nuclear power plants, the raw material for the most devastating bombs, a symbol of modern energy and the fear it entails. It is heavy, dense, radioactive, but also a generator of heat, electricity, and promise. In reactors, uranium fissions to release controlled energy. In weapons, it does so to unleash catastrophe. Its duality is brutal. It can illuminate cities or wipe them out. It represents the vertigo of absolute power, the dilemma between advancing or destroying. Uranium is the threshold of human control over the atom, and it reminds us that the more power we have, the more responsibility it demands. What happens when uranium decays? Neptunium is born, the first transuranium element ever created by humans. A radioactive, unstable, yet useful metal, it's used in neutron detectors, reactors, and nuclear studies. Its name honors Neptune, god of the oceans, following the orbit of Uranus. Neptunium is what remains after the collapse, a fragment of the atom that refuses to resign itself to oblivion. Its life is short, but its message is profound. Even in decay there is value, even the unstable can be necessary. It is the messenger of what comes next, of what challenges the classical order, of what doesn't exist on Earth. But still, we create. Plutonium, the name that makes you tremble. A symbol of extreme power and absolute destruction, but also of scientific advancement. It is the heart of atomic bombs and of space probes that have left the solar system. It glows dimly in the dark. It constantly generates heat. It doesn't exist in nature. We create it, we control it, or so we think. Its name honors the god of the underworld. Not by chance, plutonium represents the threshold, the point of no return, the energy that can illuminate or devastate. And it reminds us of something. The most dangerous thing is not what is wild. It's what is born in our laboratories, in our decisions, in our ambition. Do you want to detect smoke in your home? You probably do so thanks to americium, a synthetic, rare, radioactive metal, but one that has saved millions of lives. It was discovered in the 1940s at the height of the nuclear war and owes its name to America. But its history goes further. Americium is the symbol of the unexpected, a dangerous element that protects, a byproduct that becomes a tool, a threat that becomes a guardian. In every detector, a small amount of this element silently watches. And if there's danger, the alarm sounds. Americium is just that, what you don't see but is ready to protect you. The brilliant paradox of the periodic table. It's named after Marie and Pierre Curie. And it's not just a tribute, it's the radioactive echo of their legacy. Curium is a synthetic, extremely radioactive element created in laboratories. It's not found on Earth, but it has been used in nuclear generators and in research. It glows in the dark. Literally. It's part of the invisible fire that drives science. Curium is not just a metal, it's a biography. It's the story of two scientists who gave everything, even their health, to understand what cannot be seen. Each atom of curium is a testament to curiosity, to risk, to the limitless human desire for knowledge. What do you call an element discovered at the University of California in the midst of the nuclear age? Berkelium, like the city of Berkeley. Born in reactors, forged in the heart of atoms. It's rare, artificial, and almost impossible to study. But it opens the door to the world of actinides. And what is it for? Today, it's for almost nothing practical. But in the language of science, that doesn't matter. Berkelium is the explorer of the invisible. The key to new theories. The link that allows us to understand how elements behave beyond uranium. Its presence in the table is a declaration. There are things that aren't used, but are essential for progress. Berkelium is one of them. Californium. The element born in the same city as the technological revolution. Discovered in Berkeley in 1950, it's one of the most expensive and potent metals ever created. Its use? Incredible. It's used to start nuclear reactors, to detect oil layers, even to treat certain types of cancer. With just a few milligrams, it can release millions of neutrons per second. But it's not found on Earth. We create it in laboratories, atom by atom. Californium represents the expensive, the controlled, the one used with tweezers because it can change everything. An element that doesn't forgive mistakes, but that opens impossible doors. Einsteinium, yes, named after Albert Einstein. But its story is just as extraordinary. It was discovered in the remnants of the first thermonuclear explosion, as if the universe had whispered its existence to us amid atomic fire. It is extremely radioactive, fleeting, and complex. You will never see a sample with the naked eye, but its existence has allowed us to understand how matter behaves beyond what is known. Einsteinium is not used, it is studied. It is the reflection of a genius in the form of a metal, brilliant, elusive, transformative. What remains when the most brutal energy of man reveals an atomic jewel? In the midst of the Cold War, American scientists analyzed the remnants of a nuclear explosion. And there it was, fermium, an element that cannot be produced in visible quantities that lives only a few seconds. But in that fleeting instant, it reveals secrets of matter. It is named after Enrico Fermi, the father of modern nuclear physics. And like him, it is intense, brief, and decisive. Fermium is the particle of the instant. It appears, shines, and decays. But it leaves its mark. It is the reminder that even the ephemeral can forever change what we understand as reality. It was the first element, produced atom by atom. An achievement of surgical precision. Mendelevium is named after the creator of the periodic table, Dmitri Mendeleev, and it honors him greatly. It serves no practical purpose, yet. But its creation was a scientific feat, fishing for a single atom in a sea of radiation, studying it, understanding it. Mendelevium is just that, the pure effort of science to complete the map of the universe. It is the echo of order amid chaos, the symbol that understanding the whole requires exploring every last invisible corner. The name says it all, Nobelium, in honor of Alfred Nobel, creator of the prize that celebrates the greatest human achievements. It was discovered in the 1950s, in the midst of the race for the impossible. It's unstable, difficult to study, extremely rare. But it represents something greater, the quest. It has been used in research exploring the limits of the atomic nucleus. You won't see it, you won't touch it. But it's an atomic medal of knowledge. Nobelium isn't useful, it's symbolic. It's the prize science gives itself for having come so far. Lawrence is the last warrior of the actinides, the one who closes an era in the periodic table. Its discovery was a nearly impossible challenge, detecting a few atoms among billions. But its name honors Ernest Lawrence, creator of the cyclotron, father of particle accelerators. Lawrence has no practical applications, but its existence is a feat, manufacturing the invisible, isolating the improbable. It represents the threshold of what we can know before entering the realm of the artificial. It is the exit door for natural elements and the entrance to the territory of the nuclear gods. Rutherfordium is a radiant tribute to Ernest Rutherford, the man who split the atom. This element, as fleeting as it is legendary, only exists for seconds before disintegrating. But in that minimal time, it speaks to us of nuclear stability, of structures we cannot see but that sustain reality. It was one of the first elements created by humans in colliders. Rutherfordium is not useful, it is a message. It reminds us that science is not only useful for building, but also for understanding. It is the ephemeral flash that illuminates an eternal corner of the universe. Dubnium. Soviet power in atomic form. Discovered in Dubna, Russia, its name encapsulates the tension of the Cold War. It was created by two teams competing for the same secret, and ended up being named after the place where science became a battle. Dubnium is unstable, rare, and has no commercial applications, but it's a symbol of something larger, scientific ambition taken to the limit. Each dubnium atom lasts so little that it can barely be studied. But in its fleeting passage, it holds the codes of matter. It is the whisper of an era when knowledge was geopolitical. Seaborgium is named after a man in life. Glenn T. Seaborg, one of the few scientists honored to see his last name printed on the periodic table while still breathing. He was a pioneer, a discoverer of elements, an architect of the atom. Seaborgium is extremely unstable, but its symbolism is eternal, science honoring its own heroes. There's no practical utility here. Only the legacy of decades of pushing the boundaries of the possible. Seaborgium is just that, an atomic monument to human perseverance. Bohrium. A name that carries the weight of a theory, in honor of Niels Bohr, one of the fathers of quantum physics. This element only exists for milliseconds, but every millisecond is precious to scientists. It was discovered after decades of failed attempts, as if it refused to enter the periodic table. Bohrium is of no use to industry, but it is valuable to history, because it represents the balance between what we understand and what we barely intuit. It is nature's quantum nod to one of its greatest interpreters. Hassium is a fleeting flash in the laboratory. An element that lives mere milliseconds, created atom by atom in colliders. Its name honors the city in Hesse, Germany, where it was first achieved. But beyond the geographical homage, Hassium represents extreme atomic engineering. Manipulating unstable nuclei to glimpse new frontiers of matter. It has no practical use. It isn't in any product. But its existence demonstrates that we can create structures beyond the natural, that there is a hidden periodic table beyond the one we learned in school. Hassium is the whisper of a secret table, the promise of elements yet to be dreamed of. Meitnerium isn't just an element, it's scientific justice. Its name honors Lisa Meitner, the physicist who deciphered nuclear fission, but was forgotten by the Nobel Prize winner. This artificial element, with an extremely short lifespan, isn't found in any ordinary laboratory. But it represents a moral victory, science recognizing those who paved the way without applause. Meitnerium disintegrates in moments, but its name will live on. It is history's answer to a debt. It is an invisible monument to silenced intelligence. Every atom of Meitnerium screams, she was there too. Darmstadtium, a cold name for a hot experiment. Discovered at the GSI Center in Darmstadt, Germany, this element was first synthesized in 1994. It lasts only a fraction of a second. It has no applications. But its discovery was a milestone, forming new atoms by colliding others at speeds close to the speed of light. Darmstadtium is pure science, exploring what doesn't exist in nature, manufacturing what only occurs in dying stars or human laboratories. It is the frontier, where physics becomes creation. An atom that exists only to say, we haven't seen everything yet, Roentgenium is a shining nod to Wilhelm Röntgen, the discoverer of X-rays. Although this element does not emit rays, its name is a tribute to a scientific revolution. Like many transuranic elements, it has only been seen in minuscule traces which disappear instantly. But that transience does not make it any less valuable. Every atom of Roentgenium is a triumph of human knowledge over chance. It does not illuminate bones, but it illuminates ideas. It represents a science that recognizes its lineage, that does not forget those who saw the invisible for the first time. Roentgenium does not shine, but it honors those who did. Copernicium. The name is colossal. Nicholas Copernicus, the astronomer who moved the Earth from the center of the universe, gives his name to this artificial element. Copernicium is heavy, unstable, almost unobtainable. It has been created in German laboratories since 1996, but only a few dozen atoms are known. It lives for milliseconds, but its symbolic charge is immense. It is a bridge between the cosmic past and the atomic future. It isn't used in any practical application, but it represents the spirit that drives science, doubt, calculation, and a shift in perspective. Like Copernicus, this element challenges the center. It is an atom orbiting the truth. Nihonium is the first element to bear a Japanese name, Nihon, which means Japan. It is an atomic triumph of a country that, after nuclear devastation, became a scientific benchmark. Nihonium was created in Japanese laboratories in 2004, and although it lives for mere milliseconds, it represents decades of quiet excellence. It is as ephemeral as a sakura and as precise as a haiku. Nihonium is a symbol of memory, of progress, of that which flourishes even when the world seems to be burning. It is invisible, but it matters. It does not endure, but it transcends. Flerovium is a tribute to Georgy Fliorov, a Soviet nuclear physicist who pioneered research into heavy elements. It was created in Dubna, Russia, and its existence, though fleeting, is a victory of atomic engineering. It is so unstable that it barely allows itself to be studied, but its creation proves that the limits of the periodic table are not yet written. Flerovium represents the improbable becoming real, the atom born under impossible conditions, matter crossing the boundaries of the known. It is a sigh of things to come, an echo of what we do not yet understand. Moscovium. The name itself suggests power and gravity. It was created in 2003 by Russian and American scientists in collaboration. It is a synthetic element, extremely heavy and unstable. But its symbolism is potent. It represents cooperation between former rivals, dialogue between laboratories separated by ideologies. Moscovium has no practical applications, but it does have a moral utility, reminding us that knowledge is stronger than division. Each atom of Moscovium is an atomic truce, a flag of science raised over the past. Livermorium is a tribute to the Lawrence Livermore National Laboratory in the United States, where some of the world's most advanced nuclear technologies have been developed. As an element, it is brief and elusive, but its name connects the history of atomic research with the present of applied science. Livermorium is a piece of that secret map that extends beyond uranium, where atoms do not exist on Earth, but do in our ambition. It represents what only the mind can sustain. Matter that is not matter, the limit turned into a laboratory. Tennessee is one of the latest elements added to the periodic table. Its name comes from the state of Tennessee, home to major research centers like Oak Ridge. It's a Group 17 element, like chlorine or iodine, but its behavior remains a mystery. Because Tennessee is almost unobservable. It lives less than the blink of an eye, but it exists. That's enough to change the history of chemistry. Tennessee represents the frontier of the measurable, the edge of scientific language. It's not what you know, it's what you're about to discover. Oganesson is the last known element. Atomic number 118. It closes the table like an elegant abyss. Beyond it, everything is hypothesis. Its existence is brief, its behavior unexpected. Although it belongs to the group of noble gases, it might not behave as such. It was named in honor of Yuri Oganesson, a pioneer in the synthesis of super-heavy elements. Oganesson is not useful for building, illuminating, or healing. Its function is another, to challenge our certainties, to demonstrate that we still do not fully understand matter. It is the final note of a symphony that is not yet finished. The silence that speaks of the next universe, the mystery made atom. You have reached the end of a unique journey, 118 elements, 118 stories. A table that is much more than chemistry, it is the secret language of the universe. If you have felt curiosity, wonder, or even beauty in all of this, then you are already part of something bigger. This is not the end, it is the beginning, because Visualpedia does not stop here. Very soon we will explore the eternal principles of physics, the enigmas of philosophy, the myths that still breathe in history, the secrets of animal life, an audio-visual archive of human knowledge, made to last, made to ignite. Subscribe if you want to be part of this living library, and if this video has given you something, save it, share it, revisit it when you need to remember that knowing is also a form of resistance. This was Visualpedia, and we are just getting started.